Problem 9 changes things around a little bit. Instead of consuming power, in this case we're generating power using solar cells. So the problem says a solar cell generates 175 watts in direct sunlight. A homeowner places 10 such panels on the roof of his home. And part A says, how much energy does the homeowner generate in 5 hours of sunlight? So we use the same formulas that we've been using. So energy is power times time. Keep in mind we have to take into effect that there's 10 panels producing power. So we have 175 watt panels operating for 10 of them. And we're operating those for 5 hours of sunlight each day. And that lets us produce 8,750 watt hours of energy. For part B, we're trying to figure out how much money that saves us. So 8,750 watt hours is equivalent to 8.75 kilowatt hours, and that's how PG&E sells us power. When we multiply that by $0.25 per kilowatt, per kilowatt hour, we find that it saves us about $2.18 per day. And for part C, we're investigating how long the owner could run a number of light bulbs given this power budget. So if he was charging up batteries, how long could the owner how long would those batteries last given the amount of power that we're feeding into the batteries every day? So to do that, we again use energy equals power times time. The amount of energy we're dealing with is, again, 8,750 watt hours. The amount of power we're dealing with is 20 watt light bulbs, and there are 30 of them. And then we're multiplying it by an amount of time which we're determining, and that's what we're solving for. So when we solve that equation, we end up with T equaling about 14.5